Hello everyone, we will see the formation of depletion region in PN junction diode. Consider a single crystal of a pure semiconductor, that is intrinsic semiconductor, could be of anything silicon or germanium. Consider that half of this crystal is doped with trivalent impurity atoms so that it gets converted to p-type region, and the other half of this crystal is doped with pentavalent impurity atoms so that it gets converted to n-type semiconductor. When the doping process is complete, you will have large number of holes on p side which are shown by the hollow circles and very few electrons on p side which are not shown here. Similarly, you will have large number of electrons on n side which are shown by filled circles and very few holes on n side which are again not shown here. The holes are known as majority charge carriers on p side, whereas electrons are known as majority charge carriers on n side, and the electrons are minority on p side, whereas the holes are minority on n side. As soon as the doping process is complete, there will be a formation of imaginary junction, metallurgical junction between the two regions, which is shown by this solid black line. Now, as soon as the junction is formed, you will have a concentration gradient of the majority charge carriers of both types, that is, holes are very large in number on p side but very few on n side, and electrons are very large in number on n side but very few on p side. And because of this concentration gradient, the natural tendency will set in of the charge carriers to move from higher concentration region to lower concentration region. So, holes will move from p region to n region on their own naturally, and electrons will move from n region to p region on their own naturally. Remember here one thing, that each hole in the p region is attached to a negative ion, that is, the negative ion and the hole together form a neutral atom. But why we are saying like this is the reason, because when the hole leaves the atom, what is left behind is the negative ion. Similarly, every electron on n side is attached with a positive ion. When the electron leaves the neutral atom, what is left behind is a positive ion. We have not shown these ions attached with every hole or every electron in the diagram just to get rid of the complexity of the diagram. So, as I told you earlier, as soon as the junction is formed, because of the concentration gradient, a natural tendency of the flow of charge carriers from higher concentration region to lower concentration region will set in, and that process is known as diffusion. So, this is how the holes and electrons will diffuse into the opposite regions. As soon as they diffuse into the opposite regions, they meet the oppositely charged carriers and disappear. They recombine with each other and disappear. So, what would be left behind is the negatively charged ions on p side and positively charged ions on n side. So, there would be a region shown between these two black lines, dotted lines, which contains only the ions now, and this region is depleted of the mobile charge carriers, holes and electrons. It contains only the immobile charge carriers, negative ions on p side of the junction and positive ions on n side of the junction. This region is known as a depletion region. The name suggests that it is depleted of the mobile charge carriers, holes and electrons. This depletion region acts as a barrier now for the further diffusion of holes from p to n and electrons from n to p. So, the diffusion process stops after the formation of depletion region.